Welcome to Green Time. I'm host Don Fitz. This episode is about Passivhaus, the building. But before we get into the issues of building a Passivhaus, we're going to see a few more minutes from the movie Passivhaus, the Building Revolution.
The term Passivhaus refers to buildings that are so well insulated and sealed that they no longer need a conventional heating and cooling system. Passivhaus construction is different than passive solar. Passive solar buildings were designed to collect energy from the sun using large areas of south-facing glass, often causing overheating during the day and cooling off at night. Instead, during the winter, Passivhaus buildings rely on keeping in the heat that is naturally present in a building from the sun, people, TVs, computers, and other appliances. And in the summer, south-facing windows are either shuttered or shaded to eliminate solar heat gain, greatly reducing the need for cooling.
Solar orientation is really important when you are working with the Passivhaus planning package and trying to achieve a Passivhaus. It shows you on a couple of different spreadsheets how much of your heating demand is going to be met by the sun and how much of it you then have to make up for with mechanical means.
In most climates, all a Passivhaus needs is a small backup heating or air conditioning system, such as a mini-split heat pump, for extremes of hot and cold weather. The Passivhaus standard requires that buildings use no more than 15 kilowatt hours per square meter of living space per year for heating and cooling. 15 kilowatts is similar to the amount of energy used by a hairdryer or a small space heater. Building very low energy buildings requires the use of energy modeling software.
The heart of the design process with Passivhaus is using the Passivhaus planning package, or PHPP, that was developed by the Passivhaus Institute in Germany, that allows you to do energy modeling of the building and also is quite good for optimization and design. The Passivhaus Institute generates climate data files for specific locations, but it's very nice because it dials it in quite tightly. This is kind of where I do most of my design work. These are the particular envelope measures. These are the inputs, and these are the results coming back from PHPP. So for instance, the air tightness right now is set at 0.6, which is the maximum allowable for a Passivhaus, and my annual heating demand is 12.4. If I change that to 6, which would be typical air leakage for a standard house built in the U.S., it goes up to 49.2. So a major difference just from that air tightness. I think it's a very good verification tool. You put a building in here and it gives you what's been field tested to be a fairly accurate result.
Green building is something that began in the 1990s. There were over 100 different green rating systems around the country, but energy wasn't as important at that time as it is today. If you could get a 10 to 15% improvement, you were happy. Now we're learning today that those green buildings of the past are not too much different than conventional buildings when you have to reach an 80% reduction.
If we take a look at the energy performance of buildings in the U.S., the number 100 represents the current U.S. building code. Existing homes, most of the 113 million houses and apartments in the United States, are at the top of the chart. They typically use 30% more energy than a new home built to code. The EPA's Energy Star standard for a new home, at 85, uses 15% less energy than the average new home. The U.S. Green Building Council's LEED program begins with the same energy goals as Energy Star. Some of its higher ratings use less energy. The Department of Energy's Building America program reduces home energy use by 40 to 50%. At 15, Passivhaus is the only building standard that cuts energy use by the amount needed to meet CO2 reduction goals. Once this level of energy savings is met, homes with solar panels can more easily achieve a rating of 0.
As we're seeing fossil fuels being depleted, we're going to see energy, costs skyrocketing, and as that happens, people living in passive homes are going to be protected from that. They're going to still have a low energy bill no matter what the units of energy cost.
Welcome back to time, we just a few minutes of the movie Passivhaus, A Building Revolution. With me, I have some people who know quite a lot about constructing a passive house, the first passive house in Missouri, as a matter of fact. I have Ralph Wafer. And Ralph, tell me the company you're with.
Well, the firm is Ralph Wafer, Architecture and Planning. That's my firm. It's an architecture design firm.
Fantastic. And I have Anthony Garavaglia. Anthony, who are you with?
Trumpet Constructors.
Trumpet Constructors. So you were involved in constructing a passive house.
Yes, sir.
Okay, now tell me, what's the difference between a passive house, constructing a passive house and constructing a regular house?
Well, a regular house doesn't have a certification along with it that basically substantiates it's a green or a sustainable type of a home. And Passive House does have that. So there's many different certifications out there. Passive House is one of them.
Okay, so it has a certification, and it's going to be different in terms of the actual way that you construct and the way that you build it.
That's correct, yes.
Okay. What are some of the features of the one that was just built at complete, I believe, towards the end of 2013 in Dogtown, or middle of 2013 in Dogtown?
Well, I'll start. It's a 2,200 square foot house. To achieve the passive house standard, it was determined that for example, the floor, which is a concrete slab, this building has no basement, has an 8-inch rigid insulation underneath the slab. That's pretty unique. That does not happen in any conventional building at all.
It's just a lot thicker.
It's a lot thicker. It goes from one side of the house to the other. It's continuous. The exterior walls are insulated concrete forms with an R value of 50. The roof is...
Now what does R value mean?
Thank you. It's an insulation. It's an insulating value. So the higher the number, the greater the insulation that assembly of materials provides.
Okay, could you give me an idea of if you went to a typical house in St. Louis, I'm sure there's not such a thing, but the average house, say, what would the R value be?
Well, let's talk about an average new house,
okay,
which would be a wood frame house with drywall on the inside. It would be built with 2x4 frame construction. The cavity formed by the 2x4 wood is 3.5 inches thick. It would have batt insulation, fiberglass batt insulation.
Insulation for 3.5 inches.
Which has I'll say R value, but it has an insulating value of 13.
Okay.
That's its thermal insulation value, but it has air can move through that.
Okay.
So in our building, we have considerably greater insulating value. We also have a wall through which air cannot move. It's a concrete wall with insulation on the outside, insulation on the inside.
Okay, so the insulation is considerably more.
Insulation considerably more, and the other feature that really sets a passive house apart from other houses is we use the term infiltration, and what that talks about is air moving from the outside into the building, and it moves. In the house I live in the house you live in, and most other houses, it moves continuously. It comes around windows.
In my house, I can feel it moving.
It comes around doors. It comes through any one of a number of places. In this house, we designed it so that we'd minimize the air movement, but to really make sure it doesn't happen, when it was being constructed, Anthony and the crews that were working for him were caulking every opening, every possible place where there was a joint between two different materials was being caulked so that air cannot get through.
Well, the biggest problem that I have in my house is squirrels chewing through the window air conditioning side frame. So does a passive house prevent squirrels from chewing through?
It does not, because you don't need to build it out of ICF to be a passive house. It could still be a 2x construction type of a method.
Okay.
So.
Okay. Well, let me ask: is it necessary the insulation panels and the concrete standards? Are those necessary for passive house standards?
They are not. What is critical is the R value itself and the tightness of the home, and also the air changes, the ventilation of it. So those three factors. So
basically, you're using more insulation, you're using thicker concrete, but the issue is what the overall insulation is of the home and of the overall movement of air.
Exactly.
And it's the result you have and not the means that you use to get there.
Exactly.
Right. Oh, that's okay. Very good to know. Okay, we're going to take a break, see another portion of the movie, Passive House, A Building Revolution, and we'll be back in just a few minutes.
There are three ways to use life cycle analysis on a building. First is to use it to evaluate the energy consumption, secondly the CO2 generation, and third the building costs, both the initial cost and then the operating costs.
And I've seen that Europeans looking at the life cycle of building, how you build a building off-site and on-site and the impact and the waste that it does. Then you get to the point where you're in the house operating it, where passive house then becomes really important. Then there's the demolition of a building and the recycling of a building.
The first step in life cycle analysis is to look at the embodied energy, and that's the energy to construct the building. The second aspect is the recurring embodied energy, because those materials wear out and have to be replaced. So you have a small amount of recurring energy that's taking place throughout the lifetime of the building. Third is the operating energy that begins the day the occupant moves in, and that operates continuously until the building is no longer being used. And that's principally for heating, cooling, appliances, entertainment, all the plug-in loads that some people call them.
Combined, these represent the total energy use of a building. But if the initial embodied energy is increased during construction to meet the Passive House standard, you greatly reduce the operating energy the building will use, and also the total energy used over the life of the building.
Doing life cycle analysis on cost is different than doing it on energy. Passive house and the conventional house will be roughly the same in monthly payments. The mortgage payment will be higher for the passive house, while the utility bills will be lower, and it'll be roughly a wash. But that's for the first 30 years. After that, suddenly there's a huge bonus because you paid off the mortgage, but if you have high utility bills, you don't see much savings. With the passive house, you'll see savings which over the lifetime will add up to tens of thousands of dollars. We're told now by all our governments that we have to reduce our CO2 emissions 80% by 2050. So we need to know the CO2 emissions of a house. And when you look at the CO2 emissions of a passive house, it does actually meet that 80% reduction today.
Over 60 years, the CO2 emissions of a passive house are nearly 1 million pounds less than what is used by a standard home, or even by homes classified as green.
Understanding the building, insulating it well, air sealing it, giving it a good mechanical system, and all these things in new construction can cost the same or less. And then we have the problem of all the existing buildings that need to have the reductions done.
I've wanted to do environmental construction for a long time. We felt that the U.S. Green Building Council LEED program was filling a niche, but we wanted to do something that was really ahead of the curve and was an exemplary project. Passive House really is a cutting-edge energy standard, and if people are concerned about global warming, buildings use, we've heard the numbers before, 40% or whatever it is of the energy use in the country. And so I wanted to try to build an example here in Yellow Springs, Ohio, to show that this is possible, that we can actually make a dent in something like that. And this house is going to cost $100 a year to heat and cool. I think that's a pretty powerful statement.
In about the year 2000, I became aware of Passive House as an approach to design, and I literally stumbled on it using search engines, looking for things like low energy housing, design, passive heating and cooling, and this thing came up that said, what is a passive house? And I clicked on it, and I ended up at the Passive House Institute website and devoured the whole website and thought, this is exactly what I have been aiming to do.
This is the first retrofit in the country to be certified to Passive House levels. When we went into it, we just didn't know if it was going to work. The architect and I traveled to Germany, saw what they were doing there, and realized very quickly that America needs to pick up its game on energy efficiency. Over there, they've been dealing with these buildings for 20 years. The nice thing is they've made lots of mistakes, and we can learn from it.
one of the concerns people have when they hear about Passive House. Is it going to look different? Is it going to operate different? And the only things I would say is it'll look the same and operate better.
I designed this house and built this house 12 years ago, and it felt somehow vaguely dishonest to just leave it as a regular old, as Kat and Mike would say, a dinosaur house. I want it to last forever and be enjoyed and used as shelter forever.
I'm very energy conscious and been involved in a lot of energy issues. I lived in Minnesota before I moved here. Was involved in many energy activities up there. And so I'm conscious of the concern about peak oil and climate change and being more efficient in our lifestyles, reducing our carbon footprint. So I've decided to retrofit this house to come to close as possible to Passive House standards.
One of the nice things with ElectroShield's building is that the 15 to 20% reduction includes an adding of about 1,500 to 1,800 square feet. So we have more square footage, more lighting in that square footage, more heating and air conditioning, and we still have the energy savings.
In 5 or 6 years, we will be able to reduce the energy demand of an existing home by 60 to 80%. In each of these retrofits, the most important part of that revolution is increased efficiency. There are a lot of possibilities with very high costs, like building new nuclear plants, but the reduction of the existing energy losses, this is a low-cost concept.
Welcome back to Green Time. I'm host Don Fitz. With me I have a couple of guests who know a lot about constructing Passive House in Missouri, in St. Louis, that goes right along with the movie that we just saw, Passive House, A Building Revolution. I have Anthony Garavaglia. Got that right?
Yes.
And tell me again what company you're with?
Trumpet Constructors.
Trumpet Constructors. And Ralph Wafer. And who are you with?
Well, I have the architecture firm, Ralph Wafer, AIA, Architecture and Planning.
Okay. Now tell me, how do you achieve the air tightness standards of a Passive House? That seems like it would be really difficult to do.
Well, with an
because you don't. If a lot of air is moving in and out of a building, it's not going to be well insulated because the cold air is going to come in the winter and the hot air is going to come in the summer. Correct.
Correct.
So you want to keep the air. Like I always tell the kids next door when they come over to my house, please don't stand there with the door open and close the door so the heat doesn't get out.
Well, fresh air is obviously not a bad thing.
Okay.
Like even in your house, getting
right.
the air moving through there isn't bad. What we don't want to do is bring in the moisture from the outside,
okay.
allergies, things of that nature. So with this house, there's something called an ERV, an energy recovery ventilator, and
okay.
what that does is bring in the outside air, but it tempers it, and it also removes the allergens and things like that, and then it exhausts it out.
Because sometimes in the summer, I don't want to have an air conditioner on to cool me off because I have a sleeping porch in my house, but I might want to sleep in the air conditioning because it filters things out. But the Passive House already has that.
In this particular case, we put in an ERV, and this Passive House does have that, yes.
Okay, so it's not necessarily in a Passive House, but it's something you would want to ask for you or any person who might stay in your house.
Well, since a Passive House is so tight, you're not going to get any of that outside air without an ERV. I mean,
okay.
It's just not going to happen with the Passive House.
Okay. Well, I have a question about those air tightness standards because it seems a little strange to me how you could achieve them. When last time winter was coming on, I was there. I found out something that when I'm putting in storm windows, taking out the screens and putting in storm windows, that the corners just don't fit. And no matter how many times you swear, no matter how much profanity you use at the storm window, it's still, if it's not square anymore, it doesn't fit. And so I had a couple of storm windows that were actually sticking out a little bit around the edges. Now, if that's true in any house, isn't a Passive House going to have problems later on when the construction is, when it starts to crack or things like that or settle?
I would say so. If it's not constructed properly and,
okay.
and there are shifts and cracks and things of that nature, then absolutely.
Okay. How is it possible to construct a Passive House properly so that does not occur and you don't get the air infiltration?
Not only a Passive House, but any house is if constructed properly, You know, shouldn't now, you know, geological, you know, earthquake, something of that nature.
But your settling
could affect it. But I mean, your normal settling, all that is factored into your foundation design. You know, you do soil samples and all that was done on this house, and it could be done on a regular house as well.
The key is what he just said, is designing the foundation. In our house, we designed the foundation. You know, I used a structural engineer to help me design it, so we used just the right amount of concrete, no more, no less. But you do soil test at any building, whether it's passive house or conventional, you need to do the same thing.
Okay, so a lot of those cracks were that they did, maybe they didn't do that in the 1920s.
I think that's probably true. In residential construction, one uses rules of thumb all the time. And you really, that doesn't get you very far.
That's good to know, because it was on the back of my mind, how could you actually build a house to passive house standards? Yeah. Okay, but let me ask you this. Are there any other distinctive sort of characteristics of the house that went up in Dogtown in 2013?
Well, I would say it's essential to the passive house that you have a great deal of south-facing wall, that you have the right number of windows to absorb the solar heat gain in the wintertime, to allow the sun to come through and heat. It's a key element to heating the house. So so any in our case, we have a one-story portion of the house, and then essentially a two-story portion of the house, and the one-story portion is in the south, the two-story portion is behind it. And there's windows in both walls, the first floor wall of the lower portion, the second floor wall of the higher portion. So the sun gets into all the rooms and provides heat in the wintertime. And it's also just, obviously there's light everywhere. So that's just an added benefit, but it was critical.
So the windows not only provide heat, they provide light so that you won't have to burn as many light bulbs.
That's true, but it's essential in the calculation for achieving a passive house standard that you make sure you're getting the right amount of solar gain in the winter. Too many windows would throw that off, and you would create a problem for yourself. Too few would do the same thing. So it's part of the design and part of the calculation to meet the passive house standard to get that right.
Okay. We just have a minute left, but is there time to cover any of the other exterior features of the passive house that went up in Dogtown?
Certainly. We use a synthetic stucco product called EIFS. It's an acronym for Exterior Insulated Finish System, and it's basically taken the place of stucco these days. And what's nice about this house and being an ICF is you already have a nice substrate. The foam provides a beautiful substrate. You just come and rafts down the foam, and then you can put on the product. And it's basically just a troweled-on application. And these owners like contemporary and kind of like the southwestern theme, so this ICF application and the synthetic stucco was a perfect fit for this job.
Fantastic. Now, let me ask you this: does a passive house have any role for trees in it?
Well,
it seems it's almost contradictory, because you want trees block the heating in summer, but that's where you want the windows opening so they can get the heat in winter. Is that correct?
Right. And so a deciduous tree, obviously, it's going to make a tree that loses its leaves in winter is not going to create a problem, but a tree that does not will. So in our case, the landscape planning is really being done by the owner, but he understands the concept. So he's not going to plant a big pine tree that's going to block any south-facing window.
Okay. We got just a few seconds left. Anthony, is there anything else that you would like to say about Passive House, about why you think it's an important concept in construction?
Well, I think it's a great certification system that is easier to understand and easier to abide by than other certification programs out there.
Okay, so some of them...
Because it's a standard.
Some of them, like LEED, might be very complicated.
Exactly.
Okay. I want to thank both Ralph and I want to thank both Anthony for coming to this episode. I want to thank our viewers for tuning in, and I hope that everybody looks at Green Time this time next week.